This week, we'll take a look at the ellipsis and what you can use it for in Python. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week, I want to talk about an operator that you may have seen or may not have, which is the ellipsis. We know what they are in writing. They're three dots that mean, well, we can leave these things out. They're inconsequential or easily figured out by using context clues. But context clues aren't normally what we think of when we're thinking about programming. Computers do exactly what we tell them, or that's the idea. So let's see how we can use the ellipsis to infer things, and it's mainly used in NumPy. So I'm going to create some arrays here. A two-dimensional array. I'm going to use the mp.ones function, which just gives me an array of ones. In this case, 5 by 5. A three-dimensional array. It's going to be 5 by 5 by 5. And a four-dimensional array, which is going to be 5 by 5 by 5 by 5. Okay, so now we've got our arrays. Let's look at a simple slicing operation. In the two-dimensional array, if I want to get the 0th thing in the 0th dimension, and everything else in the next dimension, I'm going to use an empty slice there, and I get one dimension back. I'm specifying one dimension on a 2D array and getting everything else in the other. For my three-dimensional array, that's going to look like this. I have two dimensions in which I want everything, so I've got to have two empty slices there, and I get a two-dimensional array back. And just for completeness, let's do the four-dimensional array, 0 and 3 colons, and I get a three-dimensional array returned. That's all well and good, but wouldn't it be great if I could just use one expression and get the same result? Well, it turns out we can. And that is where the ellipsis is going to come in first. My two-dimensional array, 0, and then dot, dot, dot. And I get the same result. Three-dimensional, 0, dot, dot, dot. And I get the same result. Notice I don't have another comma here. So the dot, dot, dot means from context or from the size of the array that I'm dealing with, just put as many empty slices as you need to fill out the dimensionality of what I'm asking for. Now, you don't have to put it at the beginning or the end. You could put it in the middle. I could have a 3D array, dot, 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 0. In this case, it looks the same because these are arrays of ones. So this is really handy for being able to use one expression on arrays of unknown dimensionality. Maybe you know that the first dimension of your array is always going to be time, and that's what you want to index into, but you don't know how many other dimensions there are in the array, or you don't really care. You just want to get everything in the first time dimension. Well, you can do that now. Again, with 4D array, we could do the same thing. 0, dot, dot, dot. So it's just a more generic way to write your code to deal with arrays that may be of different sizes. So you might write your code right now to work with a 2 or a 3D array, but in the future you might end up passing higher dimensional data to it, and if you've written it like this, well, it's future-proof. Now, you can't have more than one ellipses in a slice, and that's because it can't infer what you want to do there. That's asking it to do some mind reading. The ellipses just is going to fill in as many empty dimensions as are needed in that one spot. Now, that doesn't mean, for example, that I can't specify more than one index. I could specify 0 element in the 0th dimension, dot, 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 and 1, 2. And now I've specified 3 indices for a 4-dimensional array, so I'm getting back a 1D array. It may not be the most useful slice. Let's do 0, ... and 2. So that same slice could work on a 4-dimensional array. It could work on a 3-dimensional array. And we get 1 dimension back. What about a 2-dimensional array? Well, look at that. It actually still works. We get 1 element back. The ellipses didn't need to fill anything in, so they didn't. So again, a really nice way to make your NumPy code more versatile. One other interesting use of the ellipses that I've seen and have started using myself a little bit. Let's say I'm writing some functions for my new script or working on something in a library, and I'm outlining how things work, how I'm going to break up a calculation. So I've got a function to write. Now, I'm not going to implement this function yet. I'm still figuring out how to break my calculation down. So formally, I do something like pass. Then if I call it, just nothing happens. And that works pretty well. And I can search for pass, though I do have it in other places in my code sometimes. But I can also have another function to write ... And this is also valid. So just another handy way that you can use this. It is an easy marker for your eye of I need to go back and implement this, and something that's easy to search. I hope that you found this useful, and I'll see you on next week's MetPy Monday.